So just like last week, I wanted to go over an example video that goes through example code. So here I have a function that is called find values. It has two outputs and two inputs. You can see I have it documented here, but my inputs here, input is an array of numerical values, and then types is identifying what types of numbers. So positive numbers, negative numbers, even numbers, or odd numbers. And then my outputs is the count, identifying the number of values of that type in my input array. And then values are the values in the input array that correspond to the types. So let's go ahead and look at the code to see what it's doing. So here I have an if statement. I have 1, 2, 3, 4, 5 different options. So type here, my input type, is being compared with 4 different known types, and then here's my default. I could also use a switch statement for this because I'm comparing text to specific known values. So type equal to positive, equal to negative. I could say switch type and then case positive, case negative, etc. So I could also write this with a switch statement. But if type is positive, then I'm going to do this. If type is negative, I do this. If type is even, I do this. If type is odd, I do this. If type is default, if it's none of those previous ones, then I do the last thing. So I'm choosing between one of 5 options depending on what my type is. So if my type is positive, then here I have this line of code. I'm saying values equals input greater than 0. This is logical indexing. This is what I mentioned in the video being super important. Here I'm saying grab all the values in my input array that are greater than or equal to 0, that are positive. Values then here is going to be a set of numbers in input. So it's going to take the values in input that are greater than or equal to 0 and put them one at a time inside of my values array. Same thing for negative. If my type is negative, I do the same thing, but now I'm grabbing the values that are less than 0. If the values are even, then I'm going to go ahead and grab the values that are even by checking to see if the remainder, so here I take input divided by 2 and check to see if that's equal to 0. That checks to see, or if the remainder equals to 0. That's going to check to see if it's an even number, because if you divide something by 2, it should have no remainder. Here, I'm grabbing the values that are even by checking to see if the remainder of input divided by 2 is equal to 1, because that tells me if it's an odd number. And then if my type is not positive, is not negative, is not even, is not odd, if all of these previous questions are false, then I'm going to execute this. I'm going to say my values equals NaN, and I'm going to display to the command window that I have an invalid type. And the last thing my code does, which is outside of my if statement, so this is always executed, it's going to go ahead and take count as the length of the value. So this tells me how many values were of that type. So depending on what type is, I'm going to do one of 5 things. Grab the numbers that are positive, grab the numbers that are negative, grab the numbers that are even, grab the numbers that are odd, or determine it to be invalid. So that's how we interpret this if statement here. Notice this type equals positive, that's a single question. It's single true, single false. And the reason for that is because I have single or double quote strings. It's a string scalar. If I had single quote strings, I would need to use string compare. So that's my function. So then let's go ahead and jump over to this, which would be my script file. So here I have a script file. I'm going to go ahead and create a vector with random values between -50 and 50. That's what this code does. So 10 is a 1 by 10. So it could look something like this. Yeah, I have it down at the bottom. It could look something like this, where vec equals 41, -50, -8, 16, 23, 3, -40, 13, -38, and 37. And then I have types. So this is an array of string scalars. I chose to do it this way because they're all different lengths. So positive has 8 characters, negative has 8 characters, even has 4 characters, and odd has 3 characters. Those are different lengths. So I'm going to go ahead and just call them string scalars. So they're all treated as scalar values, 1 by 1s, single individual values, single individual variables. And then I have counts equals 0, 4, 1. This just generates an array of 0 that I'm going to go ahead and modify with my code down here. So now I call my function 4 different times. So I use the name. The name of my function is find values. Find values takes 2 inputs. So my first input here is my array of vector values. And then here, my second input is a string corresponding to the type. So the first here, types 1, is the first value in my types array. So that's positive. Types 2 is negative. Types 3 is even. Types 4 is odd. Then I have 2 outputs. So find values has 2 outputs. The first one is my count. So I store the positive count inside of counts 1. So this goes my positive count, my negative count inside of number 2, my even count inside of number 3, and my odd count inside of number 4. So that's where I store my answers. And then I have a vector of values. So this will contain all the positive values inside of this vector array. Negative will contain all the negative values inside of that vector array. Even will contain all the even values, and odd will contain all the odd values. So when I call my function, it's going to go ahead and take the input arguments, send them to my function, use vec for input, use types 1 for type, execute the code inside here. Whatever count and values end up being are going to be passed back to my function and stored here and here. And it's going to repeat 4 different times. And then here, I go ahead and display my results. So first I print out this line here, print out some text, type counts values, and then I print out each of these lines here with a bunch of fprintfs. So first I print out a string and a integer. Those values come from types 1, counts 1, so that prints out this and this. And then I print out a bunch of integers in this array. So this array has more than one value. So it's going to print out integer space, integer space, integer space until it runs out of numbers. So integer space, integer space, integer space, integer space, and then it's going to print out a new line. So then go to the next line. And then it repeats the same thing for the remaining values inside of my types and inside of my counts. But that's how it prints out. So you can see it prints out nice and neatly down here. So for this array, for this set of values, if I check and grab all the positive values, there's 4 of them. And it prints out 16, 23, 3, and 13. So these are all the positive values. So that's what it looks like to do logical indexing. It's going to grab, so this was vect, where vect is greater than or equal to 0. For this one, grab all the negative values, which is the other ones. So this was vect, where vect is less than 0. That's what it looked like inside of my function. Even values, it grabbed even. So grab those. That was vect, where the remainder of vect comma 2 equals 0. And here's my odd values, where the remainder of vect, comma 2 equals 1. So we can see we can grab specific values out of our vector using what's called logical indexing here. And then I use an if statement, a branching statement, to decide which line of code to execute depending on which numbers I wanted to grab. The positive numbers, the negative numbers, the even numbers, or the odd numbers. So that goes over most of the different things that we learned about, or that we are going to learn about in this week. You can see in a nice set of code. If I see it executed over here in MATLAB, here is my function down here at the bottom. Here is my script. If I run my script several times, I can see for this values, here's the positive, negative, even, and odd ones. If I run it again, I can see it grabs the different set of numbers every single time, depending on what's stored inside of my vector.